the conference organizer, and thank you very much, Jeff and Terry, for joining us today at the 2026 World Digital Conference for Social Development held in the United Nations. Now, first of all, I would like to begin with congratulations on your two receiving the 2026 World Digital and Frontier Technology Scientific Breakthrough Award for inventing the Boltzmann machine. So this invention in 1980s, as well as a more recent version that enabled layer-wise deep learning about 20 years ago, has profoundly influenced many researchers' work, including my own research on speech recognition and on subsequent financial engineering work with the similar but much noisier and higher dimensional sequential data to this date. As highlighted in the nomination, your work on Boltzmann machine represented a paradigm-shaping breakthrough that establishes neural computation as probabilistic inference within the energy-based framework. It is a privilege to speak with you both today. So the first question that I have for you concerns your legacy and intellectual persistence. And many scholars and commentators highlight the intellectual persistence you have demonstrated during a few long periods when neural network has fallen out of favor. Today, research often prioritizes rapid incremental progress. Now, the question for you is, what guideline would you offer to those pursuing unconventional ideas that may take decades to bear fruit? And how can one distinguish a promising but unfashionable direction from a true dead end? Both of you probably can comment on this question.
So I would just like to first of all start by saying thank you very much for giving us this award. This is really quite an honor. Thomas Kuhn wrote a book about scientific revolutions, and he pointed out that they typically are discontinuities, like quantum mechanics, right? It was a discontinuity from classical mechanics. But following that is basically normal science, which is incremental advances and so forth. And we've actually lived through two of those. And there were in the 80s. It was really very exciting. Not necessarily earth-shaking, but at least within our small group, we had workshops, and then we got a lot of publicity for the neural network revolution. And this is where the Boltzmann machine came from, that era. But then, as you point out, there was a long hiatus of 30 years where incremental advances occurred. And now we're living through the second revolution. And Jeff can probably tell you more about that than I can.
Thank you.
Yeah, I can comment a bit on how you tell the difference between a real breakthrough and a dead end. It's when you get to the dead end. But it takes a while to recognize you're there. So my advice for young researchers is, if you have an idea that other people say is silly, but you think is sensible, just keep working at it until you realize why it's silly. Because almost all the ideas you have, if other people think they're silly, it's because they're silly. And you've misunderstood something. So you have to realize that most of the time, when you think one thing, everybody else thinks something else, you'll be wrong. But don't give up until you understand why you're wrong, because then you can learn from it. And too many people just give up due to peer pressure. You should ignore peer pressure. Just give up on the idea when you understand why it won't work. And just occasionally, it does work. And backpropagation was like that. Boltzmann machines, it took us a long time to understand why they won't work. They had a lot of impact because they showed that you can learn to do sensible things with hidden units. It's just that reaching thermal equilibrium is very computationally intensive for large systems with big weights. And that's why they weren't practical. But nevertheless, they led to a lot of other things.
Yeah, that's a wonderful answer. I appreciate it very much. Like about 15, probably 16 years ago, you came to Microsoft to work with me on Boltzmann machine. I was so excited about this. And then all this history really brought
if I
back
could
to my
comment
mind.
about that, I came to Microsoft. I was in your office typing on your keyboard to change some code, and you were so excited you started typing on the same keyboard at the same time.
Yeah, I remember. Because I just saw that I was so excited about the kind of new ideas about unsupervised learning. And then when you type, I think you change image, not image at that time. You use the
It was the learning.
image data.
It was restricted
Yeah.
bolts machines, and I was changing
Yeah.
it so that it could use real valued inputs. We had it with binary inputs and real valued hidden units, and you wanted it with real valued inputs and binary hidden units.
Yeah, and then for that reason, you change Boltzmann machine so that you can accept the Gaussian kind of units as input. So I was so excited about this. So we started working, for quite a while until we realized that it's very hard to scale up. But anyway, that was a great history.
One other comment about that will amuse people. We were at Microsoft headquarters in Redmond, and I was there for 3 weeks. And during that time, I failed to get my own computer account. I got an account for a day, and then they realized I was staying more than a day. So they said, oh, you can't have that kind of account. But in the 3 weeks, they didn't manage to give me an account.
Yeah. Yeah, I know. That was the 2009 or 10 around time, about 15 years ago.
2010.
It's about 2010. That was just a wonderful experience. You taught me how to, run Boltzmann machine layer by layer learning. And I'm still using that today, for some kind of problems that I'm facing with. Thank you so much.
Can I add a footnote to that? Could I just say that it's true that the Boltzmann machine is not practical for the reason Jeff gave, that you have to come to equilibrium, but it is actually a much better model for how the brain might actually learn because of the fact that the learning is all local. There's no global back propagation. And it also is generative. In other words, it's not just giving you an output, a label. It's actually generating probability distributions. And if you clamp the outputs, you can get examples of inputs from that distribution. So in some ways, it's more elegant. And I actually, from my perspective, I really still think that it was much more elegant than backprop.
Yeah,
I completely agree. It was a much better idea. It just didn't work very well. And it did.
I do have a.
It was generative AI way before that was fashionable for neural nets. It was one of the first generative neural nets.
Yeah. So it's important to know that that's not a true dead end. Right? This is just the beginning, and I do have a follow-up question related to this in a moment. Now, I would like to go to the second question that concerns the synergy between two of you, the masterminds. And you have collaborated across decades, bridging cognitive science and computational neuroscience with artificial intelligence. Now, reflecting on the origins of the Boltzmann machine, how did this interdisciplinary convergence make the breakthrough possible? Was there a particular moment when a biological insight and a computational constraint came together to crystallize the idea of Boltzmann machine model?
I can tell you exactly the moment. I can tell you we were sitting at a meeting in Rochester. And by the way, in those days, meetings consisted of about 20 people getting together. And John Hopfield was giving a talk, my former thesis advisor, talking about his Hopfield network. And Jeff and I had already been collaborating on trying to build models for vision, constraint satisfaction models. But we suddenly realized that from his background in psychology and computer science and mine from neuroscience and physics, that we could heat up the Boltzmann machine, the Hopfield network, that is to say, by making it probabilistic. And that really was the kernel that led us to really make this breakthrough. And I still, that era was just so exciting. I still look back at it, very fondly.
One curious twist to that was that just before that, I'd been in San Diego working with David Rommelhart, and Paul Smolensky and I had actually programmed backpropagation. And because it needs a continuous derivative, we were using logistic units. and so when you heat up a Hopfield net, when you make it noisy and give it temperature, what you get is logistic units. So that was one of the things that made me realize that Terry's idea that you just heat up a Hopfield net actually led to things I was used to, which was logistic units. And then very soon after that, we realized the logistic unit is the right way to combine evidence. If you have evidence from multiple sources. So yeah.
Wow,
It was
very
fortuitous. The other thing was Terry had recently read a paper by Kirkpatrick about simulated annealing, and Terry immediately realized that you could put Hopfield nets together with simulated annealing, and that's what led to the idea of the Boltzmann machine.
Oh, that's a wonderful story. I didn't realize that. I'm glad that I hear this wonderful story. Speaking about Boltzmann, go ahead.
No,
Terry, go ahead.
The real breakthrough was Jeff called me one day. I was at Hopkins at the time, and he was at Carnegie Mellon, and said, "Terry, I just worked out some equations for a learning algorithm for the Boltzmann machine," and that was the breakthrough. That was really the breakthrough because it made it possible to do hidden units.
Yeah, to me, I remember when Jeff, you were with Microsoft. The first thing you told me is that the simulation typically would take infinite number of samples, right? And then you said that you can turn that into just 3 or 4. It's going to work well, and that really excited me. I said, "Wow, that probably is going to make that feasible." So I took it very, very seriously. I bought like 3 GPU units at your recommendation. Tried to run quite a bit. That was about 15 years ago. It turned out that it turned out that when we have large amount of data, with some better initialization, that layered learning pre-training became less effective. And in particular, at that time, we didn't have that residual connection, architecture, right? So in that case, we couldn't. I went up to only about 15 or 16 layers, with our speech data at Microsoft. And then everything saturates, couldn't, get any further improvement. And until eventually we realized that that using restricted Boltzmann with layered version, we called the deep belief network at that time, right? It wasn't the real key, element of making deep neural network. That's a very interesting story. So I learned that's tremendous. I realized that now the data is important, the computer is important, but also architecture is important. Once we got into, eventually, we learned from Microsoft, from Beijing at the time with the residual connection. And that architecture really just, dismissed the power of the Boltzmann machine for a long time. Hopefully, eventually it will come back.
So when you look back on it, it's clear that using stacked residual restricted Boltzmann machines to initialize a net, what it was really achieving was just sensible initial values for the weights. And there's lots of other ways of doing that. But the restricted Boltzmann machines had lots of nice math that went with them to do with variational bounds. And so that made it sort of very respectable. And in that sense, it was a bit like support vector machines, which have lots of nice math that go with them that make them respectable. But that's not the main thing.
Yeah.
And in fact, you have to give up on that nice math if you want to make support vector machines practical too.
Yeah, this is just a wonderful part of the history. So the concept of the pre-training started at that time, right? And now when we talk about large language model, we have different kind of pre-training. That's very, very important as well. But the key difference now is that we actually use the backpropagation to do pre-training, and then also we do the next word prediction, and that gives kind of much richer, larger amount of non-supervised data compared to many years ago, where we need to use the Boltzmann machine, the big belief network to do initialization. It's a different paradigm of doing the pre-training, but the concept of pre-training was really seated by the work that you introduced to Microsoft like 15 years ago. That was just a wonderful experience. So let me move to the next question about the path to AGI. Now, in preparing for this dialogue, I spoke with many of my former and current colleagues, including one of the current leader at Microsoft, help sort of leading the large language model post-training at Microsoft, Dr. Chen. And then he told me to share that question for you. And we both would like to value your perspective on the following three aspects of AGI. And the first, I think not just us, but everybody would like your both of your precise working definition of AGI. And also, we would like to know what specific Turing Plus benchmark would indicate that AGI has been reached. And finally, we would like to know how might AGI, when it arrives, can reshape the roles of PhD students, faculty, and scientists in industry. And do you foresee the traditional role of the scientists fundamentally changing or even becoming obsolete? I'll give two of you to answer these questions.
Let me start by saying something about the term AGI.
Yeah.
The term AGI treats intelligence as though it's a one-dimensional thing, like you just get more and more of it. But it's very obvious that it's highly multidimensional. And so the idea that there'll be a point at which it's equal to people is crazy. It's going to be jagged relative to people. That is, it's going to be much better than us at some things. Well, it's still much worse at other things. So it's a silly term. Now, the term superintelligence isn't so silly. The term superintelligence means it's better than us at almost every intellectual task we do. We believe that's coming. But that's a reasonably defined term, whereas AGI, it's just a silly term because it assumes that intelligence is one-dimensional. So already, for example, the large chatbots are hugely better than any person at general knowledge. You can ask them what the filing date is for taxes in Slovenia, or how you damp-proof the porch of a house. You can ask them any question like that, and they'll know the answer quite well. So they're way past us in things like that. But they're still not quite as good as us at some kinds of reasoning. They're better than most of us at math already, particularly me. So I think AGI is a silly term.
Okay, I agree. I completely agree with Geoffrey, but I would like to add that there should be a warning flag here when all the experts cannot agree what AGI means. And this reminds me of another word that has similarly difficult scientific merit, which is the word consciousness. In other words, there's hundreds of books written about it, and it's still completely misunderstood or not understood. Do animals have it? And it's AGI falls in exactly the same, I think, limitation. If you can't define a scientific term in a way that everybody agrees on, then you're not going to make progress.
Well, that's a wonderful answer. Yeah, by the way, actually, over the past few days, I got a chance to read your book, ChatGPT and Deep Learning Revolution. You wrote two books. So the newer book is much better than the old ones.
Well, thank
that
you.
was wonderful. I realized that you probably use ChatGPT to write part of your book. The way
Well,
I read.
I did, except that whenever I used it, I flagged it. I had boxes where I asked ChatGPT a question, and you could judge for yourself whether the answer was correct.
That's very good. It's amazingly good. I'm curious to ask you how you actually provide the prompt. Do you have to do multiple rounds?
No,
in order to
no.
get the
In
kind
fact,
of
I
answer
was
you
very
put in the
naive
book?
back then. I actually everything there was the first prompt. You saw the first prompt.
Wow.
I couldn't have gone on, but that was my goal. I wanted to demonstrate, the strengths and weaknesses.
Yeah, that's wonderful. 2 years ago, GPT was already able to write part of your book. That's wonderful. Okay, so now
I want to just comment on something Terry said about how we can't define consciousness. And I agree. Scientists can't define it very well, but in everyday use, we seem to manage to use the word to communicate. And when scientists aren't thinking about philosophy, they're just thinking about science. They assume that these chatbots are conscious. And you see that there's a wonderful paper that talks about a chatbot and the chatbot asks the people who are prompting it, it says to them, now let's be honest with each other. Are you testing me?
Yeah.
And when talking about that, the scientists say the chatbot was aware that it was being tested. Now, in normal everyday conversation, that's one of the times we use the word conscious, for when you're aware of something. And the chatbot was aware that it was being tested. So the scientists are already treating it as if it's conscious.
Yeah, that's wonderful. This is a wonderful result. Yeah, so let me move to the next question. And Geoffrey, you once shared with me when you worked with me at Microsoft many years ago that your early PhD student called Peter Brown played a pivotal role in shifting speech and machine translation from symbolic to statistical methods before moving on to become a CEO that leads and to lead the famous finance firm called the Renaissance Technologies. While much of modern AI has gravitated towards deterministic architecture such as transformers, optimized for relatively clean data like text, audio, speech, image, videos, my own work and many of my colleagues in finance AI deals with incredibly noisy, non-stationary, and high entropy signals. Now, in your view, maybe for both of you, my energy-based stochastic models like Boltzmann machines, do you think they may be inherently better suited, at least conceptually, to such messy domains such as finance than the largely deterministic architecture currently dominating natural language processing? I'd like to hear both of you, your views on this.
So let me say something that Ilya Sutskever commented on years ago. And it was a little comment he made that seems very sensible to me, which is, we all know that the right way to do probabilistic reasoning is to be Bayesian. You have to combine your prior beliefs with what the data is telling you. And there's a particular way you should do that by adding log probabilities. Now, if you train up a big neural network using backpropagation, it may not be doing the computation exactly as a Bayesian would have done it, where the Bayesian would have tried to separate out prior beliefs from evidence. But it'll look as though it's Bayesian. If it's doing a good job, it'll behave as if it's Bayesian. So the point is, deterministic systems can behave as if they're doing Bayesian reasoning. And I think that's what these big models are doing. So basically, they can fake it.
Can I add a footnote? Okay, so we don't actually know how the human brain is able to solve these problems. And I think it's very unlikely that there's a Bayesian network somewhere with all the priors and all of the conditional probabilities that you need to really make it rigorous. But I think in the same way that at least qualitatively, that you can get something that behaves as if it were Bayesian. I think that's what we can see happening in the human brain. It approximates a Bayesian reasoner, but it's not. I think there's a lot of evidence against it.
Oh, so thank you very much for the.
One nice thing about restricted Boltzmann machines is if you look at the weights between the visible and the hidden units, those weights are not the prior, but the prior is implicit in them. So those weights are involved in both incorporating the evidence that comes from the visible units and in defining the prior. Because if you run the restricted Boltzmann machine with no input, it'll settle to a distribution. That's its prior, and that's defined by the weights. But when you get input, those same weights will be used in determining the states of the hidden units. So the restricted Boltzmann machine is a nice example where it is actually doing correct Bayesian reasoning, but that doesn't involve having a separation of the prior from the parameters you use for incorporating evidence. The weights in restricted Boltzmann machine are encoding both those kinds of parameters. They're not separated.
This is wonderful. This is wonderful insight here. So my next question is concerning biological plausibility and the next paradigm. And you both championed biologically inspired computation at a time when it was far from mainstream. That was many years ago. And as contemporary AI becomes increasingly engineering driven and less biologically grounded, do you think the field drifts too much from the insights that made the Baltimore machine possible?
Okay, this is a great question, and let me just tell you how we were thinking back in the early days.
Yeah.
The only existence proof that any problem in AI back then could be solved was that nature had already solved them.
Yeah.
And that's uncontrovertible. They could not solve any problem back then. They could not do language translation. They couldn't do vision.
Yeah.
50 years, $100 billion that went into writing programs for vision, and you know, compared to what we have today, they weren't even off the ground. They weren't even Wright brothers level. So,
Terry, if you remember, Terry, we were at a conference, and we talked to I think he was a general in the CIA who'd been helping fund AI vision, and he said a wonderful thing. He said this was about traditional AI methods for doing vision. He said, "You guys can't even recognize a blob."
Yeah.
That's where things were. That's where we were. You know.
Wow, this is wonderful. And then finally, which current line of research, perhaps still considered unfashionable, do you believe might hold the potential to become the Baltimore machine of the 2020s or 2030s that may spark the next major leap in AI? Do you think modeling neurons, you know, some dynamics in the neurons may hold some of the key? Because now the network is very, very sophisticated, right? You know, very large architecture-wise compared to brain. Maybe it's still far away, but the neuronal properties have hardly been modeled. So in the current neural, I want to hear your opinions.
Yeah. So Lee, you're asking the wrong people. You should be asking our students that question, because we have already gone through that process. And as you know, our intuitions, are best when we are young. Okay, so that's my answer.
Yeah. Interesting.
Jeff may have some better ideas.
Yeah, I'd love to hear Jeff's opinion on that.
Well, I do have one thought, which is currently, if you look at AI vision and AI image generation, they're sort of more or less separate. That is, you have these, you have ResNets, which are good at vision, and you have a way of generating data that generates wonderful images. But your way of generating data doesn't allow you to extract good representations from images, because so you can think of neural nets for generating data as a special case of the wake-sleep algorithm. So in the wake-sleep algorithm, you generate data during sleep, and from that data you generated, you learn to get the hidden representations from the lower level representations. So you generate top down, and once you've generated, you learn to recover what's in the higher layers from what's in the lower layers. So you've got a generative system that allows you to learn a recognition system. Now, the generative system for our current neural nets consists of, the recognition system consists of take a real image, add some noise, and that gives you your first hidden layer. Then add a bit more noise, that gives you your second hidden layer. Then add a bit more noise. So your recognition process just consists of adding noise. That's not a very good recognition process, and it's not going to lead to very good representations of the image. But it's good enough, so even using that really dumb recognition process, you can actually generate good images by inverting it. So it's really half of the wake-sleep algorithm. It says, let's freeze the wake phase, the phase that recognizes things and gets underlying representations from images. Let's freeze it at something incredibly dumb, just adding noise. And that's still good enough so we can produce really good generative models. So it's obvious to me what people should do. They should say, well, we're using a really dumb recognition model. Why don't we first use that really dumb recognition model and use a really good generative model. Then why don't we try inverting that generative model? So rather than making our generative model be just add noise, make our generative model be use a ResNet. In a ResNet, basically what you're doing is you're copying and then changing a little bit.
Yeah.
And that's what adding noise says, copy and change a little bit by just adding some Gaussian noise. Well, suppose our ResNet, instead of just copying and adding noise, which is the dumbest possible ResNet, what you do is you copy and do something that you've learned to do, which is better at inverting the actual things you've generated. So you could imagine slightly improving your generative model, sorry, your recognition model, by trying to invert your generative model. After you've trained a really good generative model, once you've now got your slightly better recognition model, you could use that for generation and you could just go in that loop. So I see what's happened at present is we have these ResNets that are good when you train them supervised for doing recognition. And we have these good generative models that are using an incredibly dumb recognition model, but still work very well. Those two should be combined.
Yeah.
So as usual, Jeff has just shown you his brilliance, and it reminds me of the many times I get a call from Jeff, and it would start the following way. Terry, I just figured out how the brain works. It was always a brilliant idea, and in some cases actually was really had an insight into the brain. Like, for example, your idea about the weight, throwing away the weights or throwing away the units. That's right. So I think there's still hope for us, Jeff.
Yeah, very much so.
That allows me to tell one more funny story, which is
many
years ago, I came down for breakfast one day early, and my daughter, who was having breakfast so she could go to school, said, "You're down early, Dad. Why are you down early?" I said, "Emma, I've just figured out how the brain works." And she said, "Oh no, Daddy, not again."
Not again. Okay. Oh, this is a wonderful story. But it shows that per your earlier comment asking the young people this kind of question, I think Jeff and you both are young. You're still
I have another
useful
useful idea for young people, which is you can actually weigh how good your ideas are, or you can weigh how interesting your ideas are. And the way I would do it is, my weight is fairly stable, but when I had a really good idea, I wouldn't have time to eat anymore, so my weight would go down. So I could weigh how exciting the ideas were by how much my weight went down.
Yeah. And then I remember you have been pursuing capsule model for many years. Is it considered to be still promising idea, or is it going to think it's going to be at that end?
That's a very good example of the dangers of being extremely determined. I was convinced it was a really good idea because it's kind of generalizing convolutional nets to do more than just be translation covariant. I was convinced for a long time it was a very good idea, even though people I respect were telling me, "Jeff, you should give up on this. It's not going anywhere." They were right and I was wrong. So the cost of being very determined is you can spend 5 whole years on an idea that in the end doesn't work out.
So is it the problem with the idea, or is the problem of computation? Because they don't fit backpropagation easily, right? Is it the main reason why you stop it?
It's hard to know. The main reason I stopped it was I hadn't got it to work in 5 years and now I was too old.
Oh, I see. Well, still, it's not the end, right? I love the idea. I listened to many of your presentations on that. I just thought that, well, if I were young, I would start working on similar kind of
There
work.
has to be a solution to this, Jeff. I mean, maybe not capsules, but the brain, as I said, nature has already solved these problems. So my guess is that that's where we're going to find the answers.
Yeah. It's wonderful. In the interest of time, let me have one final question before I hand it over to the conference organizer. And that question is more in alignment with the mandate of our conference organizer, the United Nations Research Institute for Social Development. And the question is as follows. Now, both of you have spoken publicly and with growing urgency about the existential and societal risk posed by increasingly capable AI systems. but the communities most likely to be harmed first are not the ones sitting in the rooms like this one. They are the workers whose jobs are being automated without safety nets, the populations in the global south, whose languages, cultures, and governance systems are largely invisible to the models being built, and the citizens of countries that have no seat at the table where the rules are being written. Professor Hinton and Professor Sejnowski, do you believe the current international governance architecture is even remotely adequate to protect those communities? I'd like to hear your comment on this. It's a very, very different kind of question.
I have a very clear comment. No.
Yeah, please. Okay.
That's absolutely right, Jeff. That the things are moving so quickly that no government can possibly catch up. I mean, it's really you might have a rule, that is relevant right now, but and who knows? A week later, there's a big breakthrough. Mythos, right? Suddenly comes up, and now the rule is obsolete. But something you have to keep in mind in terms of every new technology has benefits and risks attached to it. Yeah. And you just go through a list of them, but every day, every year, people are dying on the roads because of the automobile that was invented 100 years ago. But we're willing to live with the risk, right? And so there will always be a risk with AI. But what's, I think, not taken into account, which is the fact that as a new technology takes hold, you learn, the unexpected problems, and you adjust as you go up to the point where it becomes, you're able to adapt to it. Society has to adapt, and as I'm always asked when I give a public lecture, will I lose my job? And my response, and this is my first book, already had this, which is that you're not going to lose your job, but your job's going to change. And if you want to keep your job, you're going to have to learn to use new tools. Yeah. And that is what's happening. So I think that's where things are going to head. It's that there are whole new jobs are going to be created. People who know how to use the tools will benefit and will thrive. And it's the young people. For young people, there's no problem because they can. They're just they don't have to worry about the old jobs because they have new ones.
Yeah.
Okay.
Oh, this is wonderful.
I want to make two comments on that. The first is you have to distinguish between markets that are elastic, where if you can do more of it, there'll be a lot more demand. So, for example, healthcare and education are both markets in which if you greatly increased productivity, you would have much more of the product. You'd have much more healthcare. You'd have much more education if you made people more efficient at doing it by working with AI tools. So that's good. But there's other markets like call centers. In call centers, AI can already do those jobs about as well as people, and soon it'll be much better than people. The people who work in those call centers, whatever they retrain for, AI will be able to do it better. So they really will lose their jobs. And I think that's quite serious. The second
let's take an example, which is where this happened already with telephone. There were telephone switchboard operators. There were women mainly who stood there and plugged in, from the input to the output. And you're right. When switches were put into replace the call centers, those jobs disappeared. But whole new jobs were created and right. People now can be trained to do them, and that was a better job.
Right, but what you haven't taken into account is that if we get super intelligent AI, any intellectual job it'll be able to do. So even if new jobs are created, AI will be a cheaper way to do them. So let me make my second point, which I think is a good point to go out on before we have questions. The AI tech lobby is currently spending huge amounts of money on advertisements that are trying to convince people to use a particular analogy. We all know that people mainly reason by analogy, not by using logic. And the analogy they're trying to get over is this idea. Suppose you have a car. The accelerator is what makes progress. Yeah. And regulations are like the brake. and they're trying to sell people, we don't want regulations because they'll slow us down. They're trying to make people see it in terms of a car where AI, unregulated AI is like the accelerator and regulations are like a brake. That's completely the wrong model. We've got to get an alternative model out there. The accelerator is progress. That's what progress in AI does. It's like an accelerator. Regulation is the steering wheel. It's not the brake, it's the steering wheel. They want a very fast car with no steering wheel.
Okay, Jeff, it's even worse, because if you ever went out with a car that had no brake, boy, you are in trouble if you go down a hill.
Yeah, but you're even more trouble if there's no steering wheel. You'll be in trouble faster.
Oh, this is a wonderful analogy. Probably this is the first time I heard the analogy, right? Among all the public talk you gave. That was just wonderful.
I just thought of it a few days ago.
Oh, wow. Okay, good. This is really fresh. Okay, thank you so much. Now, before I hand over the floor back to the conference organizer, I first of all want to congratulate you again for your foundational contribution to AI by inventing boardroom machine that became the catalyst for the deep learning revolution that started, about 20-some years ago. I appreciate so much for both of you working, talking with me directly. Jeff, you even came to Microsoft to work with me in person. And Terry, I met you about maybe last New Year's, not the previous one, but the one that when you just came back from Nobel week to Vancouver, that we spent about probably the whole hour talking about, boardroom machine, all of this. I just enjoyed so much. Thank you so much. Congratulations again. So now let me return the floor back to the conference organizer. And you may have, the conference organizer may have collected some of the questions already. Yeah,
yes.
Back to you. Thank you.
Thank you. Thank you, Professor Deng. Thank you, Professor Hinton. Thank you, Professor Sejnowski, for delivering so much meaningful, funny, wonderful story and truly inspiring dialogue. So now let's open the floor to our audience. So who want to be the first? Okay.
We have one question from Emma.
Professor Hinton. Professor Sejnowski, this is Yale Lee of WDTA. Congratulations again. So actually, I have two questions, related questions, on behalf of most people here at United Nations Geneva office. Whether you call this, artificial general intelligence AGI, or in your term, super intelligence, it's no longer a science fiction concept. It is a timeline debate. Some in this room would say AGI or super intelligence is a decade away. Others would say we're already there in meaningful respects. Both of you have dedicated your careers to understanding how intelligence, biological and artificial, actually works. So I want to ask you something that goes beyond the policy. When AGI or super intelligence arrives, whatever form it takes, will it be possible for humanity to remain in meaningful control of systems we have created? And if the honest answer is we don't know, what does that uncertainty oblige us to do right now, today?
I think the answer is very obvious. We don't know whether we can coexist with super intelligent AI, but we're constructing it, so we still have a lot of control. And we should be careful to construct it in a way where we can still continue to exist, and we can live in harmony with it. And there's very few models of far more intelligent things allowing far less intelligent things to have freedom. The one model we know is a mother and baby. The mother really does care for the baby. But what's happening now is We're at the point in history when it's urgent to try and solve this problem, and very few resources are being put into it. Maybe 1% of the work is going into that compared with going into making AI smarter. And it's crazy.
Yeah, I completely agree with Jeff, but let me give you another insight. Again, I like to look at historical examples. So let's look at the internet. So back in the 1990s, Jeff and I were exchanging documents that we were writing, papers over ARPANET, which was the precursor for the internet. It was mainly universities that were doing research for the government. And I think, back then, I could never have imagined, I don't think anyone back then, maybe Jeff, did you foresee all of the impact that the internet was going to have on the future? In other words, every aspect of our, for example, the fact that we're having a Zoom, this WebEx discussion across the world is something that couldn't have been done back then very easily, at least. And it affects entertainment, and it affects newspaper, everything. Science is having a huge impact on science. So we don't have a good imagination. We in other words, we just don't really understand what the unintended consequences are. And I think that you really have to really worry, because there are bad, risky things that the internet has brought us that we still haven't regulated properly. So I think that's inevitable that we're going to go through. As we develop things, we'll be able to patch some things up, but maybe not others.
I think I can answer Terry's question about whether I foresaw where the technology was going by saying that I'm still copying my vinyl records onto CDs.
Oh, that's great. Wow.
All right,
Yeah,
let's
this is
go on
great.
the next question. Okay, the lady, please.
My name is Elma Alkic. I work here at UN Geneva, and I'd like to pose the question for UN News, UN TV Geneva, and UN News. This week in Geneva, there are a number of events related to AI governance, and this conversation hasn't really covered that so much. But if I can just turn it a little bit in this direction. I'd like to give a quote that Doreen Bogdan Martin, the Secretary General of the ITU, said yesterday at one of the conferences that are taking place on the AI. And she said, the widening gap between countries shaping artificial intelligence, there is a widening gap between countries shaping artificial intelligence and those merely consuming it. AI market is projected to reach $4.8 trillion by 2033, roughly the size of the world's third largest economy. But that capital is flowing to some countries. Developing countries are almost entirely absent from the top tier of AI investment. Generative AI adoption in the global north is growing nearly twice as fast as the global south. Left unaddressed, this is a second great divergence, widening gap between countries shaping artificial intelligence and those merely consuming it. Sorry, that might have been a bit long, but actually I wanted to pose a question about public responsibility and global governance. And this ties in with what Professor Hinton said about regulation is the steering wheel, and that it is urgent to solve the problem, and that at the moment 1% of resources are given to wanting to resolve the problem.
Okay, could I address that? Okay, because
I would like to pose a question, if that's okay.
Okay, what's the
on the
question?
back of this? The question is, what are the risks if AI is not designed responsibly? The United Nations is built on 3 pillars: peace and security, development, and human rights. If AI systems are not developed to support and strengthen those pillars, what are the risks in that sense, and how can we tackle this? What are the biggest risks? Thank you. And please, if I can direct this primarily at Professor Hinton.
Well,
Thank
well,
you.
wait. This is something that I think is really important, and it's something I could speak to, not as a personal perspective, but rather as the president of the Neural Information Processing Systems Foundation that runs the biggest AI meeting, because this is a question that our board of trustees actually has addressed over the years and continues to address. And I just want to give one, again, I believe in historical examples. And this occurred when recombinant DNA technology was being developed back in the 60s. And it was clear that it's got to be regulated, because if you could have power over creating new viruses that are more virulent, or you could also use the technology for curing human diseases. It became clear that it had to be regulated, and the biologists got together at Asilomar, and the best molecular geneticists at the time, and they self-regulated. They created containment levels of containment that prevented anything that happened by accident to get out to the world. And the best way to regulate it is self-regulation, because you know what the issues are and you could correct them properly. And I can tell you that there are many people in our field today who are very concerned. In fact, there's this whole new academic tracks for people who are worried about ethics, who are worried about unintended consequences. And this is something that the field, I think, really is aware of, and it's not like we're just sitting there. Now, the group that probably you're aiming at are the high-tech companies that, and I think Jeff is quite right about that. They it's not in their interest, obviously, to regulate, but it is in ours, and the practitioners, people like Jeff and me and all the others who are creating this technology, really are very concerned. And I think that we can, if we do this properly, we can do it the same way the biologists did, in a way that really mitigated the so far at least all of the bad bad people using the technology for in nefarious ways, and helping the field is a great promise. And Geoffrey pointed out that medicine and education, I think, are the two top areas that AI can really, really benefit. And I'm not talking about the whole world. I'm not just talking about the Northern Hemisphere. I'm talking about the global South, which could benefit the most from new techniques for being able to mitigate malaria and other diseases. So this is something that I think if a government, okay, and this has happened, if you start prematurely stopping research, and you're not going to be able to solve the problems. You have to understand what the problems are before you can regulate it properly. So in any case, that's my perspective from the perspective of the NeurIPS Foundation. Now, Jeff has personal views on this, and I agree with a lot of them.
Yeah.
Okay, let me just first of all say we need to distinguish three kinds of risk. There's risks that come from people deliberately using AI for bad things. So creating fake videos to corrupt democracies, creating nasty viruses to cause pandemics, doing cyber attacks. Those are three of those worst ones. Then there's risks which are a side effect of people trying to make money from AI. So things like producing pictures of naked women from photographs of women with clothes on. They're just trying to make money. Or another place is creating social divisions by getting you to click on, by offering you videos to click on that are more extreme than the ones you just saw. So you create two completely different groups of people who don't have anything in common. Those are risks that come from the side effects of people trying to make money from AI. And then there's the third class, which is the existential threat of AI itself taking over. Now, for that third one, we'll get international collaboration. For the other two, I think we'll continue to get, particularly for the first class, bad people doing bad things with it. We won't get collaboration. We'll get people saying they want to collaborate, but countries are all attacking each other this way. And that's going to be much more difficult to deal with, much more difficult to get collaboration on. Then there's one final thing I want to say that does address your question somewhat, which is, if you look at the models of tobacco and asbestos, what happened was the more developed countries that were producing tobacco and asbestos, like Canada, for example, introduced regulations in their own country that protected people, but continued to sell it to what back then was called the Third World, called the Global South. So we really have to worry about, even if we do get regulations that are steering AI in the right direction in the countries that are developing the AI, we have to worry about them still selling that AI to other countries where it has bad effects, even when they're not allowed to do it in their own country.
Thank you. We still have 2 questions more. So this side, okay, that lady, please.
Hello, professors. I'm a faculty at the University of Bath in the UK, and it was very insightful to listen to both your discussions. One question in particular, and I'm asking this from the standpoint of the United Nations and its wings that has a lot of data or records as they can delineate with lots of geospatial maps, things with textual data, visual infographics, scribbles, annotations. And these are records of correspondences dating back from the 1930s until now. So if we were to digitize that, and as Professor Hinton spoke about improving the representation learning space, what is the one signal from biology or physics that you would say is necessary to incorporate within the models to improve that representation so that we get better digitized paradigms of these documents? Thank you.
I'm not sure I understood the question. Could you sort of just state the question again as clearly as possible?
Professor, the question first,
Yes.
and then maybe we can give the floor
context,
to...
yeah, of course.
Yeah,
So-
I mean, we can collect questions first and then give them floor to answer. Could you do that? Okay, good. So we're going to have question from David over there and our intern here. Okay, David first.
Jensen, thank you for the presentation. There's another godfather of AI, and I don't like the term, but I'll just use it anyway. It's Yann LeCun, and he's recently said that he thinks that LLMs are a dead end for achieving superintelligence. I'm just curious if either of you agree with this. Why is he saying this, and what are the alternatives? Thanks very much.
Okay, so if you want to make an intelligent system, particularly one that understands about space, there's a philosophical question and a practical question. The philosophical question is, could a system that just tries to predict the next word in a lot of language ever understand about space? And I think we know the answer to that, which is yes, it could, and that's very surprising. Then the second question is that an efficient way to understand about space? And the answer is no. You're going to be much better understanding about space and basic common sense physics if you have a camera and if you can manipulate objects. So in practical terms, a multimodal AI that has a camera and can manipulate objects, as well as can talk, will be able to understand a lot of things faster with less data than a purely language-based one. But in philosophical terms, the purely language-based one may be sufficient with enough language.
Yeah, and just to follow up that line of thought, it's pretty clear that babies, when they're brought into the world, are inundated, with sensory information coming in like a fire hose, and it's all being integrated, multimodal. They put things in their mouth because they want to understand the properties of the rattle and the food and so forth. And none of that goes into pre-training. These large language models can talk the talk, but they can't walk the walk. And in my book that was mentioned earlier, ChatGPT and the Future of AI, I have 12 areas, and that was one of them, where there's a big lost opportunity for AI to vastly improve the rate of learning, the performance, and just one more that I'll give you, bias, right? you pre-train a network on the huge bias that's in the world's knowledge base, and you're not too surprising, it's biased. Well, how do babies learn the right bias? And they do it with reinforcement learning. It's another learning algorithm that's very important for especially control. And the feedback is, good and bad. Don't do that. It's dangerous. Don't do that. Don't say that because that's a bad thing to say. And that takes place during the development of the brain, when the brain is just taking in information, and it's information about the culture, not just the language, but the culture of what is acceptable and what's important, what's good and what's bad. And that's completely missing from our current technique that is being used for large language models. But that's going to change. We're at the very beginning. This is a long way before we can get to the point where we approach anything as sophisticated as the human brain.
Okay, thank you. I think this table still have a question remain, so let's take this question to this table. Any question? Okay.
This table is.
Okay.
We have one question, this table, and that table, and that table. So can you collect questions, okay? So maybe we can give the floor to the professors to select the questions. So maybe you can make your question very quick, short, please. Please introduce yourself.
Yeah. Hello, my name is Halima, and I am representing UNRIST, Research Institute for Social Development, as an intern. You have been at the forefront of AI development for decades, and you have seen its evolution from the very beginning. My question is, in short, can you envision where we respect not only people, but also the planet, the environment, when we talk about AI? Because throughout our conference today, I do not think that it was addressed, and I wonder how you would answer to this question, how we can also take environment into consideration when we talk about AI development. Thank you.
Thank you very much. Okay, gentleman over there, yeah.
Do you want us to answer that question?
Professor, we're going to collect questions, and then you can select questions as you please.
I will have a very brief question. My name is Daniel Bulba. I'm working in financial industry for MFG. Because Professor Hinton talked about the steering wheel, the metaphor about regulating the artificial intelligence and the call center example, how we should proceed in order to do not develop more differences between, let's say, the richest and the poorest in society.
Thank you very much. This table, last chance. Okay, John.
John Francis Leader from the European Federation of Psychologists Associations. A big thank you to both professors. My question to both is, you've talked a lot about complex systems of AI and the complex systems of human cognition. It's just your instincts, your intuition about what the cybernetic relationship of both those systems together is going to look like over the coming years and decades, what your intuition is. Thank you.
Thank you very much. I'll give you the floor, professors, so you can select the questions to answer. Thank you very much.
Okay, first question about the environment and AI interacting with the environment. We've all seen at present that it's leading to huge energy demands, and those huge energy demands are leading China to keep making coal burning power stations, even though China's already the leader in renewable energy, and people in the States making big gas-powered power supplies. So I think it's currently having a very bad effect. I think it has the potential to help a lot. For example, by making better materials for solar panels, or even perhaps by allowing carbon to be extracted from the atmosphere. It's much more efficient to extract carbon dioxide at source rather than put it into the atmosphere and get it out again, because that's very energy inefficient. Right now, obviously it's having a deleterious effect, and that's very bad. The core problem, though, is the system of government under which all this stuff is being developed, where big, very, very powerful big companies are just pursuing huge potential returns, and they're abandoning their pledges to be energy neutral, for example. So Google, for a long time, was a leader in moving towards being carbon neutral. I think it's sort of giving up on that now because it needs so much power, and that's a shame.
Yeah, I'd like to follow up on that. This is addressed to the United Nations, and to the first question that we kind of Jeff had trouble understanding. My understanding is, what are you going to do with all the data that the United Nations has put away over the last 50 years or longer? I think that it should be possible to use even the current technology for AI to explore all of those issues, like the environment and inequality of education in the global South and so forth. Why not just have experts in AI using that database? After all, I mean, it depends. All of these large language models depend on the data that you give them. So if you have a lot of data on all these different issues that you've explored over the decades, why not use that as a way of creating specialized AI, specialized LLMs for each one of those problems? And maybe it'll come up with new ideas, maybe it'll come up with ways of thinking about the future and so forth. But United Nations has this treasure trove of all the data there. Why not do something with it?
Thank you, professors. Thank you very much. It was a long time, but your discussions and the conversations were greatly present for all of us. And I'm really happy to have this kind of chance to listen to great minds of the 21st century or in the era of AI. So I will give the floor, Melan, so you can close the session.
Okay, thank you. Thank you. Okay, so today's discussion is really meaningful. So at the end, I want to invite 3 professors and our on-site guests together to take a group picture and ending this section. So we can, the photograph can stand behind the room, and then we can face this direction.
Okay. Photographer is over there.
Yes.
So if you want to be shown, you have to look at that side.
Yes. Yes.
Where should we look?
Huh?
You have to tweak some.
Look at the